Today's lesson is going to be pretty familiar. We saw these quadratic equations back in chapter 4 or 5, I believe it was. So it's going to be similar to that, and we're going to see a lot of similar things. It's just that now we can get answers that are complex numbers. Earlier we hadn't talked about complex numbers, so we didn't really have equations that gave us complex solutions, but now we will get some complex solutions. So our objectives, we're going to use the discriminant, which we learned earlier, and we will review again today. We're going to use that to identify equations that have complex solutions, and then we're going to be able to solve quadratic equations that have complex solutions. When we learn to solve quadratic equations in the form ax squared plus bx plus c, we really had three main strategies that we learned. First of all, we almost always try factoring first, because factoring is usually the quickest way to solve. We also learned completing the square, which we can use, and we will use that later on in this course for different things. But if you had to complete the square, it's usually just easier to use the quadratic formula, which is mentioned here. So as we look at this example here, we look at it, we could try factoring, but it's not going to end up working to factor. And you could try a couple. If you have something in mind, you could try it, but it really doesn't work to factor it. So we can use completing the square, we could use the quadratic formula. So we're just going to use the quadratic formula. So this you should have committed this to memory, that if you have something in a quadratic equation in this form here that I highlighted in green, you can find x by knowing that x equals negative b plus or minus the square root of b squared minus 4ac, that whole thing over 2a. And so we're just going to plug this into the quadratic formula and then simplify. So we are going to have, we know that 3 is our a, negative 2 is b, and c is 1. So x equals negative b, well, it's negative negative 2, so that's a positive 2, plus or minus the square root of b squared minus 4 times a, which was 3, times c, which is 1. Please put your square root over the whole thing. The whole thing, and again, another thing, put your divided by your fraction bar under that whole thing, all divided by 2a, so 2 times 3. And now it's just a matter of simplifying. Hopefully I can fit this in here. So x equals 2 plus or minus 2 squared is 4 minus 12 all over 6. Continue to simplify, 2 plus or minus, and we see here that we get 4 minus 12, which is negative 8 over 6. And we have a negative 8 in our square root, so that means we're going to have an I. So we can write this as 2 plus or minus. We know we're going to have I here. And so we have the square root of 8. And square root of 8, so let's just do a little work to the side here. Square root of 8, well, 8 is 2 cubed. And so we can think, all right, well, I'm going to bring out a 2 squared. The square root of 2 squared is 2. So 2 root 2. Okay, we learned that back in last chapter. So this is 2 root 2 all over 6. We see we have some reducing we can do. 2 goes into each of these. Each term we don't do under the square root, so 2 goes into this 3 times, once, and once. And so our answer for this quadratic equation is 1 plus 2 root 2i plus or minus root 2i all over 3. That's not written very well. I don't really have much other room. So this was 1 plus or minus 2i over 3. 1 plus or minus square root of 2i over 3. And that's how you solve We've done this before, it's just that in this case we had an I. We had a square root in our negative. Now the other objective talked about using the discriminant. The discriminant, if you remember, is the part under the square root. So the discriminant is the b squared minus 4ac. So here's the discriminant. We can use the discriminant to describe what type of solutions we have without doing the whole problem. Because we can look under the square root, and we talked through this before. If what's under the square root is greater than 0 and a perfect square, so maybe 16 or 25 or 36 or 49, any of those perfect squares, you're going to have two rational solutions. You're not going to have irrational numbers, you're going to have rational numbers. You're going to be able to simplify that square root and no longer have a square root there. If it's greater than 0, and not a perfect square, you'll end up with two irrational solutions. If it's equal to 0, you're going to end up having the square root of 0, and we get the two solutions normally from having a plus or minus something. Here you'll have plus or minus 0, so square root of 0 is just 0, so you just get one rational solution. And then this is the new part. Today we now are going to have less than 0, and we end up with two complex solutions. And those complex solutions end up being conjugates of each other. So I'm actually going to go back to this last slide because I wrote that they're conjugates of each other, and we might not readily see that. I'm going to have to get rid of some work here because we have a lot of stuff written here. So if you remember, our answer was 1 plus or minus 2 root 2 I over 3. If you want to see those as conjugates, we have this 3 that's a common denominator, so we can write 1/3 plus or minus root 2 over 3i. And now we can see it as conjugates. We have 1/3 plus root 2 over 3i and 1/3 minus root 2 over 3i. So that's where we see that they're conjugates. Here's an example. Give the value of the discriminant and the number of nature of the solutions of this equation right here. Be as specific as possible. So it doesn't ask us to solve it. We just need to use the discriminant. So we have b squared minus 4 times a times c. B in this case is 3, so 3 squared minus 4 times a, which is 2, times c, which is 4. This is 9 minus 32. 9 minus 32 is negative 23. Well, negative 23 is less than 0, so we found the discriminant. Give the value of the discriminant. That's one part of our solution, negative 23. And the number and nature of the roots. Well, it's a negative. It's less than 0. It fits this part right here. So we have 2, so that's our number, complex solutions. And they would end up being conjugates of each other. You don't have to write that as part of your answer, but so there's the second part of our answer. We found the conjugates, negative 23, and since it's less than 0, we know there are two complex solutions. And that's solving. That's, again, that's a review of what we've learned before. So going back just to our objectives here at the beginning, we used the discriminant to identify quadratic equations with complex solutions. That was the last example we just did, and we solved quadratic equations with complex solutions. And so you'll be doing both of those things and should get very comfortable with those.